Hello everyone, welcome to the next lecture on the numerical analysis. Today I will explain you how you can find the multiple roots. Myself Dr. Harish Garg, you can follow my YouTube channel where you can find the playlist of the numerical analysis. In this playlist you can see the various lectures such as the bisection method, regular falsies, secant, fixed point, Newton-Raphson methods, multiple roots and the many more lectures in this playlist. I hope you can subscribe my YouTube channel so that when I upload my next video, you will get the notification. Now, what is the target of this lecture is whenever you have the function f of x is 0, then can you find or how you can find the root of the function fx? What is the meaning of the root is? That means your target is to find the value of fx so that f of x is 0. For example, if I consider the equation x square minus 4x plus 3, fine. Now clearly say if I consider x is equal to 1, then it is my 0. What does it mean? That is x is equal to 1 is the root of the equation. However, if I consider another function like x e raised to power x minus 1, then can you find the value of the x easily so that f of x will be my 0? Then it is not an easy target for you as compared to this first example. So how you can find that? Then for that we have discussed the various methods such as bisection, regular falsi, fixed point, Newton methods and many more. All are available in this playlist, numerical analysis. But remember students, all these methods are applicable only when you have to find the root, say x is equal to xi is of the single order. Fine. That means if I consider the function like x minus 1 whole square, then clearly say what is the root of this function? The roots are my 1 comma 1. That means you can say x is equal to 1 is my double root. Fine. So but if you apply fx on these functions, or you can see you can apply any of these methods on the function fx, then you are unable to find all those 1 comma 1 root. That will give you the only one root, that is x is equal to 1, but they are not talking about the double roots. So in that case, or you can say it's a double root, that means the root with the multiplicity 2. So now the today's lecture is how we can understand the multiple roots and their significance and how we can find the multiple roots. For that we have used one of the method known as the modified Newton-Raphson method. So before that, let me explain you what is the definition of the multiple root. For the function f of x is 0, x is equal to xi is called as the multiple roots with the multiplicity m. If f of xi is my 0, fine, f dash of xi is my 0, f double dash of xi is my 0, and so on until you will get the m minus 1th derivative of xi is 0 and the mth derivative is my non-zero. That's the meaning of the multiplicity. What is the meaning? If I say f of x is equal to 0 is, okay, I will explain this example. For example here, so can you say x is equal to 1 is the root? Fine, definitely, because f of 1 is my 0. Fine, so f of 1 is a root. Now the question arises is what is the multiplicity of this root? So for that I can find the f dash. What is the f dash is? 2x minus 4, and clearly say f dash of 1 is my non-zero. Now since the first derivative value is my non-zero, therefore x is equal to 1 is the root, and what is the multiplicity is? The multiplicity is the powerth derivative. So with the multiplicity 1. Fine. This is the way you can check about the multiplicity. There is one more method. How you can find that? You can factorize this. This is x minus 1, x minus 3. Then what is the root of these equations? Roots are my 1 and 3. So clearly say 1 is occurring only one times. So therefore this is the root with the multiplicity 1. Similarly 3 is the root with the multiplicity 1. Again you can see what is the value of the f3. f3 is my 0. Fine. What is the value of the f dash x? It's a 2x minus 4. And what is the value of the f dash of 3, which is my non-zero? So since the first derivative is non-zero, Therefore, x is equal to 3 is the root having multiplicity 1. Again, you can see if I found the roots, what is my root is 1, 1 and 3. So clearly say 1 x is equal to 1 is my double root, or you can say the root with the multiplicity 3. Second way how you can check about the root multiplicity, I can found the f dash of x. So first of all you can see what is the value of the f1, 0. Now what is the f dash of x? He said twice of x minus 1 into x minus 3 plus x minus 1 whole square. Now clearly say f dash of 1 is again 0. Then we will find the f double dash. You have to find until you will get a non-zero value. So what is the f double dash is twice of x minus 3. I can use the product rule, twice of x minus 1 plus twice of x minus 1. Now clearly say what is the f double dash of 1. This is 0, but this is my non-zero. Now look at that, second derivative is my non-zero. Therefore x is equal to 1 is my double root, or double root means that is the multiplicity is my 2. Similarly you can see that here now the root is my 1 1 1 3, or you can prove that f of 1 is my 0. You can easily prove that f dash of 1 is my 0. You can easily prove that f double dash of 1 is 0, and you can prove that f triple dash of 1 is my non-zero. That means x is equal to 1 is my triple root, that is a multiplicity 3. Similarly this has the multiplicity 4. This is the first method you can check about the multiple root. Second definition is if you write the function fx in the form of the power m, where h of xi is my non-zero and m is my greater than 1 is my positive integers, then you can say x is equal to xi is the root of the function f with the multiplicity m. For example, what is the meaning of this? If you compare them, clearly say m is equal to 3. So I can say x is equal to xi is the root with the multiplicity 3, or in other words I can say f of xi is my 0, f dash of xi is my 0, f double dash of xi is my 0, but f triple dash of xi is my non-zero. So let's see. Firstly, f of xi is my 0. I can found the derivative. What is the f dash of xi? So it's a 3 times x minus xi square into hx plus x minus xi cube into h dash of x. So I can take x minus xi square common, find whatever the remaining part I call as this h1x, fine, where h1 is my this case. Now you can see now its a power is 2. When it will be the root? If you prove that h1 of xi, what is the value of the h1 xi? This value is 0. What is the value of the h of xi is a non-zero. So h1 of xi is non-zero. What does it mean? Again you can see x is equal to xi is the root of fx, but in this case f is my f dash x with the multiplicity. What is the multiplicity? The power is my 2. Fine. Now similarly again we can see f of xi is my 0, f dash of xi is my 0. You have to do until you will get a non-zero value. Then I can find the second derivative. It will be my twice of x minus xi h1x plus x minus xi square h1 dash x. So clearly say I can take x minus xi is common, and whatever the remaining part we call as the h2. This is the component which is left behind. Fine. I call this number is my h2x. Fine. And you can see that h2x is my non-zero because h1x is my non-zero. So therefore x is equal to xi is the root of multiplicity 1 of f double dash with the multiplicity 1. Now you can see that f of xi is 0, f dash of xi is 0, f double dash of xi is 0. Then we can find the third derivative. Third derivative will be my h of 2x plus x minus xi h 2 dash of x. Now clearly say this number is my non-zero because h2x is my non-zero. So therefore x equal to xi is the root of the fx with multiplicity 3. Now, so what is the equivalent definition of that? Either you can use this definition to prove the multiplicity, or either you can prove this definition. But I always recommended you that you can apply this definition because it is not an easy target for you that you can factorize that. For example, here, if I apply this definition, so power is 1. So that means if I consider this is my x minus xi, then this is my hx, and clearly say x is equal to 1 is the root. Why? Because h of 1 is my non-zero. So x is equal to 1 is the root, but the power is 1, so the multiplicity is my 1. On the other hand, if I consider this is my x minus xi form and this is my hx, then you can say x is equal to 3 is also the root, because what is the h of 3? If this is my hx, is my non-zero, is the root having the multiplicity 1. Fine. Similarly for this case, I call as x equal to 1 is the root having the multiplicity 2. X is a root multiplicity 3 and 4. But make sure student, if my function is say x e raised to power x minus 1, then it is not an easy target for you that you can factorize them. So then for such kind of the examples, I always recommended you that you can use this definition. Now graphically, what is the meaning of that? If I draw the graph of the x minus 1 into x minus 3, or you can say the square, or you can say the cubic, you can see that these are the graphical representation. Clearly say x equal to 1 is my single root, or I call as a simple root. Fine. In this case, x equal to 1, you can see this is a double root, and x equal to 1 is my triple root. Fine. So what is the observation you can obtain from that? So look at these two cases where x is equal to 1 is my double root. Fine. And in this case, x is equal to 1 is my triple root, or you can say the multiplicity is my 3. Then the sign of the function fx does not changes in the around the x is equal to 1. Fine, because the concavity is not changes. So what does it mean? If the sign does not changes, that means the bisection method and the regular falsy method is not applicable to find the roots of the double root or the multiple roots. On the other hand, because we know f is, if once we say double root, then the derivative of the function is also 0. So once the derivative is my 0, what does it mean? That means the Newton-Raphson method and the second method, either they may diverge, fine, or the convergence is very, very slow. Fine. So you can see that all these methods, that is a bisection method, a regular falsy, Newton-Raphson, and the second methods are not applicable to find the multiple roots in an efficient manner. So for that, we will need the modified Newton-Raphson method. So before I try to move on the modified Newton-Raphson method, let me explain you the certain examples so that you can get your answers to check the multiplicity in a simple manner. I hope you can like and comment on this video as well. Now you can see that you can easily factorize them, but there is no need of this. First of all, you can check whether f of any point, say 1, is a 0. Fine. Then you have to find the derivative until you have to find f dash, f double dash, f triple dash until you will get the non-zero numbers at the point 1. So what is the f dash of x? 3x square minus 2x minus 1. So what is the value of the f dash at the point 1? So clearly say this is my 0. Fine. So since we didn't get the non-zero value, then we can find the second derivative. 6x minus of 2. What is the value of the f double dash of 1, which is my non-zero? Once we get a non-zero value, there is no need to compute the third derivative. Fine. Now since f1 is my 0, f dash is 0 and f double dash is non-zero. What does the meaning of this? That means x is equal to 1 is my double root. Fine, because the second derivative is my non-zero, or you can see x equal to 1 is the root with the multiplicity 2. Look at the second example. Again, clearly say x is equal to 0 is my root, f of 0 is my 0. Now firstly we can find the f dash of x. It is my 2x e raised to power x square. Again you can see f dash of 0 is my 0. I can find the second derivative. What is the second derivative is 2 is outside, so 1 into e raised to power x square plus 2x square e raised to power x square. Now clearly say what is the value of the f double dash of 0. This number is my 0, which is my 2, and hence it's my non-zero. Fine, so there is no need to compute the third derivative. Now since what is the meaning of that? Second derivative is non-zero. That means x equal to 0 is my root having the multiplicity 2, or you can say it's a double root. Look at this case. Now this case you can easily see that because the power is my 2, so clearly say x is equal to 2 is my root with the multiplicity 2. On the other hand, x is equal to minus 5 is also the root, but the multiplicity is my 1. This is the first method. Fine. Second way you can find the f dash of x. What is the f dash of x? Twice x minus 2 into x plus 5 plus x minus 2 whole square. Clearly say f of 2 is my 0. What is the f dash of 2? Is also 0. Because we get a non-zero value, I can find the second derivative. So what is the second derivative of this? It's a x plus 5 plus twice of x minus 2 plus twice of x minus 2. Now clearly say f double dash of 2 is my non-zero. So since the second derivative is non-zero, so what you can say, x is equal to 2 is the root with the multiplicity 2. Similarly, if I say f of minus 5 is my 0. What is the value of the f dash of minus 5? This is my 0, but this is my non-zero. Therefore, x is equal to minus 5 is the root with the multiplicity 1. Fine. Now, look at the last case, 1 minus cos x. So clearly say f of 0 cos 0 is my 1. So it is my 0. If I found the first derivative, it is my sin x, which is again you can see f dash is my 0. Then we can find the second derivative, which is equal to cos of x, and clearly say f double dash of the 0 is my non-zero. So therefore x equal to 0 is my root with the multiplicity 2. Look at this another one. Find the multiplicity of the root x equal to 1 for the function. So first of all we can consider f of x is x minus 1 wholes. Now clearly say what is the f of 1, which is 0. Can you find the first derivative of this function? So this is my twice x minus 1 ln x plus x minus 1 square over x. So what is the value of the f dash of 1, which is 0. This is my 0, this is 0. Then you can find the second derivative. So again I can apply the product rule. It's a twice ln x plus 2 times x minus 1 over x. I can use the product rule or I can use the quotient rule. That's the same meaning, x minus 1 over x and minus 1 over x square into x minus 1 square. Now what is the value of the f double dash of 1? L of 1 is 0, this is 0, this is 0, and this is also 0. Fine. Or you can combine them. This number is my 2 ln x plus 4 times x minus 1 over x minus half of x minus 1 square. Fine. Then I can find the third derivative. So if you find the third derivative of this function, you will get this expression. Again you can see, because we have obtained that f of 1 is 0, f dash of 1 is 0, f double dash of 1 is 0. What is the triple derivative of 1? this is 0, this is 0, this is 0, but this is my non-zero. Therefore, what you conclude, that means x is equal to 1 is the root of the fx with the multiplicity 3. Look at the second one, another one. If f of x is my this, check whether f has a 0 with the multiplicity 2 at the point x is equal to 0. So that means what is your target? Multiplicity 2 at the point 0. Your target is to prove f dash f0, f dash 0, and second derivative is my non-zero. So clearly say f of 0 is my 0, e raised to power 0, 1. Fine. What is the f dash of x? E raised to power x minus 1. Clearly say f dash of 0 is again 0. However, what is the f double dash of x is? And clearly say f double dash of 0 is my non-zero. So yes, therefore you can see x equal to 0 is my double root of the function f of x. Examine the multiplicity of this function at the point 0. So again, we will check about firstly what is the value of the f0. Sine 0 is 0, this is 0, 0. Then we can find the f dash. Can you find the value of the f dash? Is a cos x plus 2x into cos x minus x square into sin x minus 2x minus 1. Then what is the value of the f dash of 0? Cos 0 is 1, this is 0, sin 0 is 0, 0 and minus 1, which is my 0. So since f dash is 0, I can find the second derivative. Fine. So what is the second derivative of this function? So it is my minus sin x plus 2 cos x minus 2x sin x. Again I can use a product rule, minus 2x sin x minus x square cos x minus 2. Fine. I can combine this value, it's my 4 times 4x sin x. Now what is the value of the f double dash 0? This is my 0, this is my 2, this is my 0, this is 0, and this is minus 2, which is again 0. Fine. Then I can find the triple derivative of the x. So if you find the derivative of this, you will get this expression. Now clearly say f triple dash of 0 minus 1, 0, 0, 0, which is my non-zero. So what does it mean? That means x equal to 0 is the root having the multiplicity 3. Look at this case. Show that f is a double root at x equal to 1. That means your target is to prove f1 is 0, f dash of 1 is 0, while f double dash of 1 is my non-zero. That's why it's a double root. So let's start with the f of this. What is the f of 1? 1 minus e raised to power 0 is 1, 1 minus 1, 0. Can you find the derivative of this function? It's a 0. I can apply the product rule, 1 e raised to power 1 minus of x e raised to power 1 minus. Fine. So I can take an e raised to power 1 minus x common, then it will be x minus 1. Fine. Then I can again, you can see what is the value of the f dash of 1? 0. Then I can find the second derivative. Again I can apply the product rule. The first function e raised to power 1 minus x, and 1 minus x derivative is negative, plus e raised to power 1 minus x into 1. So I can take an e raised to power 1 minus x common, that will be my 2 minus x. Now clearly say the second derivative at the point 1 is my non-zero. So therefore we can say f of x is my double. So this is the way you can check about the multiplicity of the function. I hope you can like, comment and subscribe my YouTube channel. We will see the next lecture on the modified Newton-Raphson method for finding the multiple roots. Till then, you can share this video with your friends and don't forget to subscribe my YouTube channel. Best of luck students. Happy learning.